Hello everybody, welcome into another lesson. So today we are going to talk about the algebraic method to determine if lines are parallel, perpendicular, or neither. Well, let's start with parallel lines. If we recall from review of pre-algebra in the geometry segment, parallel lines are two lines, or could be more than two, but they go on infinitely, but they never intersect. They don't touch at any point. Those are parallel lines. And then algebraically, to determine if two lines are parallel to each other, the slope of each line is the exact same. If you have the exact same slope, then the lines are parallel. Now, let's move on to perpendicular lines. Perpendicular lines are lines that intersect in such a way that when they intersect, they form right angles. So, I have this symbol here. Let's say you have two lines. Line 1 is perpendicular. That symbol means perpendicular to line 2 if the slope of the second line is equal to the negative reciprocal of the slope of the first line. Well, what do I mean by a negative reciprocal? Okay, let's go over that first. What the heck is a negative reciprocal? Let's say I have 2/3 as the slope for one line, right? I need to find the negative reciprocal. Well, let's start with just the reciprocal. What's the reciprocal of 2/3? It'd be 3/2, and then negative reciprocal, you just put a negative sign in front of it. So if you have a line that has a slope of 2/3 and another line that has a slope of negative 3/2, they're perpendicular. Or let's say I have a line that has a slope of 2. I need to find the negative reciprocal of 2 in order to see if it's perpendicular. The negative reciprocal of 2 is negative 1/2. So if one line has a slope of 2, another has a slope of negative 1/2, they're perpendicular. So, and if they're neither, that means they intersect. They do intersect at some point, but they don't intersect in such a way where they're perpendicular, so we just say they're neither. So, what we're about to do here is I'm going to put up the equation of two lines, okay? We have 3x plus 6y equals 8. Then we got y equals 2x minus 8. So we have the equation of two different lines here. Well, what it's plain to see here is that you already have one in slope-intercept form, which is perfect. That's what you need to determine the slope, right? The first one's in standard form, second one's in slope-intercept form. What we're trying to do is determine if these two lines are parallel, perpendicular, or neither. First thing you want to do, work on that first equation. Okay? Get that 6y by itself on the left side. So in order to do that, we got to subtract 3x from the left side. If you do that, you do in fact get 6y by itself. But what you do to one side, you got to do to the other. You'd have to do 8 minus 3x on the right-hand side. You're still left with y equals 2x minus 8 for the second equation. Now, we can argue that this is still not quite in slope-intercept form, but we want to get it a step closer. So what you're going to have to do is use the commutative property of addition and move that negative 3x and 8 around. So if we do that, you'll end up getting 6y is equal to negative 3x plus 8. And then you'll have y equals 2x minus 8. Alright, now, ideally, we would like to get we have 6y for the first equation. We want to get the y by itself, so we got to divide by 6. You divide 6y by 6 in the first equation, you get y. You'll have y is equal to, but you got to do it to the right side too. You divide the negative 3x by 6, you get negative 1/2 x. Plus, you have 8 divided by 6. 8 divided by 6 reduces to 4/3. So, the first equation now turns into, in slope-intercept form, y equals negative 1/2 x plus 4/3. Then you still have the second equation, which hasn't been affected, of y equals 2x minus 8. So, now, in order to determine if they're parallel or perpendicular, you're just going to look at the slopes. Alright, slope 1 of the first equation, I'll just say m sub 1 is equal to negative 1/2. Slope 2, which would be n sub 2, that's equal to 2. Well, I think it's clear to see that negative 1/2 and 2 are negative reciprocals of each other. Therefore, the two lines, we could say line 1 is perpendicular. Use that symbol for perpendicular. Line 1 is perpendicular to line 2. So these two lines turn out to be perpendicular. Alright, I got more examples here. Let's see. We have 3x plus y equal to 7 for the equation of the first line. Then we have y equals negative 3x plus 2. So y, we have 3x plus y equals 7 and y equals negative 3x plus 2. Well, the second equation's already in slope-intercept form. That's really going to help us out. But the first equation's in standard form. We need to get it into slope-intercept form. So that means on the first equation, we need to get that y by itself. So we have to subtract 3x from the left-hand side. If we do that, you do in fact get y by itself. But you also got to do it to the right side. You get 7 minus 3x on the right-hand side. Second equation hasn't moved. You get y equals negative 3x plus 2. Well, the first equation is still not quite in slope-intercept form. But we can make it so if we use the commutative property of addition and move that negative 3x and the 7 around. So, using the commutative property of addition, you get y equals negative 3x plus 7. And then the second equation remains y equals negative 3x plus 2. And I should point out that if you had the same equation for both of the lines, then it's the same line. I think that would be obvious. So it would be the exact same line, but we have two different equations, so they're definitely not the same line. Now, we have both of these in slope-intercept form. Therefore, we need to now deal with the slopes. The first slope, m sub 1, that's equal to negative 3. The second slope, which would be m sub 2, is also negative 3. Well, they have the same slope. Both lines have the same slope, therefore they are parallel to each other. So you write line 1, the symbol for parallel is this. Two vertical lines means parallel. When we get into geometry, that's going to save you a lot of grief between writing out the words perpendicular and parallel, just using the symbols. But we could say line 1 therefore is parallel to line 2 since both these lines have the same slope. Alright, what's the next one? We have 2x plus 5y equals 7. Then we have 2x plus 5y equals 9. We have 2x plus 5y equals 7 and 2x plus 5y equals 9. Both of these equations are in standard form. Let's work on getting them into slope-intercept form. In order to start, we need to get the 5y by itself in each equation. Start with the first equation, we need to subtract 2x from the left-hand side. If you do that, you get 5y equals, you got to do it to the right side, you'll get 5y equals 7 minus 2x. If now you do it to the bottom equation, you have 2x plus 5y equals 9. Okay. What you have to do now is subtract 2x from the left-hand side. If you do that, you get 5y by itself. That'll be equal to 9 minus 2x since you have to do it to the right-hand side. Now, we almost have it in slope-intercept form except for a couple things. First, in each of these equations on the right side, let's use the commutative property of addition to switch the x and constant terms around. So you'll have 5y is equal to negative 2x plus 7. Then for the second equation, you'll have 5y is equal to negative 2x plus 9. Now all that's left here, in each of these equations we want to get just y on the left hand side, so we got to divide by 5, right? Well, we divide the first equation by 5 on the left side, you get y by itself. Y would equal, now you got to do it to the right, negative 2x divided by 5 is negative 2/5 x, plus 7 divided by 5 would be 7/5. Second equation, you divide 5y by 5, you get y. Do it to the right side, negative 2x divided by 5 is negative 2/5 x. Plus you have the 9 divided by 5, that would give you 9/5. So now we have both equations that turn out to be in slope-intercept form. You have y equals negative 2/5 x plus 7/5, then you have y equals negative 2/5 x plus 9/5. Well, let's start now, since we have them both in slope-intercept form, let's deal with the slope of each line. The slope of the first line is, in fact, negative 2/5. The slope of the second line is also negative 2/5. Since they have the same slope, it is safe to say that line 1, therefore, is parallel to line 2. So line 1 is parallel to line 2. As a result of them both having the same slope. Alright, I have 3 more examples, then we're done. we got 2x minus 8y equal to 9 for the first line. Then we have 12x plus 3y equal to 7. So the equations of the two lines are 2x minus 8y equals 9. Then we have 12x plus 3y equals 7. Well, both of these are in standard form. Ultimately, we want to get them into slope-intercept form. To start, let's look only at the first equation first. 2x minus 8y equals 9. Safe to say we want to get that negative 8y by itself. Well, we got to subtract 2x from the left-hand side. So if we do that on the left-hand side, you get negative 8y by itself. That'd be equal to 9 minus 2x, because you got to subtract 2x from the right-hand side also. Now let's deal only with the second equation. You have 12x plus 3y equals 7. Safe to say we want to get that 3y by itself, right? In order to do that, you got to subtract 12x from the left side. If you do that, you do in fact get 3y by itself. You would get 7 minus 12x on the right-hand side. Well, to start with, let's use the commutative property of addition in each of these two equations to make the x term first. So you would have negative 8y is equal to negative 2x plus 9, and then you would get 3y is equal to negative 12x plus 7. Alright, we're a step closer to slope-intercept form. The only thing stopping us now is that we, on each of these equations, we want to get just y on the left-hand side. If we go ahead and do that, on the first equation, we got to divide that negative 8y by negative 8. If you do that, you do in fact get y by itself. Now on the right side, you got to divide negative 2x by negative 8. You would actually get positive 1/4 x. Then you have plus 9 divided by negative 8. That'd be minus 9/8. So for the first equation to get into slope-intercept form, you have y equals 1/4 x minus 9/8. Now let's deal only with the second equation. You want to get the y by itself, you got to divide the left side by 3. If you do that, you do get y by itself. Now on the right hand side, you divide that negative 12x by 3, you would get negative 4x plus, then the 7 divided by 3 is 7/3. Okay. So now we have y equals 1/4 x minus 9/8, and then you have y equals negative 4x plus 7/3. We have them both in slope-intercept form the way we want to. Now we need to deal with our slopes. So the first slope is 1/4. Slope 1 is 1/4. Look at the slope of the second line. The slope of the second line is negative 4. Well, 1/4 and negative 4 happen to be negative reciprocals of each other. Since these are negative reciprocals on their slopes, it is safe to say that line 1 is perpendicular to line 2. So these two lines, therefore, are perpendicular, since the slopes are negative reciprocals. Alright, what do we got here? Two more. We have y equals x plus 5. Then we have y equals 8 minus x. Alright, first equation's already in slope-intercept form. Second equation, however, is not quite yet, okay? We want to get the second equation into slope-intercept form. Well, we can use the commutative property of addition to do just that. First equation we can leave alone, y equals x plus 5, but your second equation, the commutative property of addition, would make this y equals negative x plus 8. Now, this was short and easy. Both equations are in slope-intercept form now. We're only going to consider now the slopes of each line. So the first slope is going to be positive 1. The second slope is negative 1. Well, 1 and negative 1 are definitely negative reciprocals of each other, are they not? Therefore, it's safe to say that line 1 is perpendicular to line 2. So, these two lines are in fact perpendicular since the slopes are negative reciprocals of each other. Then I have one more and we're done for the night. Alright, let's see. We have 4x plus 6y equals 9. And 2x plus 3y equals 5. Alright, so 4x plus 6y equals 9. 2x plus 3y equals 5. First thing you want to do, since both of these equations are in standard form, we want to convert to slope-intercept form. So first things first, we want to get, in both equations, get the y terms by themselves on the left-hand side. So focus on the first equation here first. We have 4x plus 6y equals 9. We want to get that 6y by itself, so we got to subtract 4x from the left-hand side. If you do that, you do get 6y by itself. But what you do to the left, you got to do to the right. You get 6y equals 9 minus 4x. Now, on the second equation, we have 2x plus 3y equals 5. Well, we want to get that 3y by itself, do we not? So you got to subtract 2x from the left-hand side. If you do that, you get 3y by itself on the left side. But what you do to the left, you got to do to the right. You would end up getting 5 minus 2x on the right-hand side. So now you got the equation 6y equals 9 minus 4x and 3y equals 5 minus 2x. Okay then. We want to make the x term first on each of these equations on the right-hand side, so we need to use the commutative property of addition in order to do so. If we do that, you get 6y equals negative 4x plus 9. Then on the second equation, you get 3y equals negative 2x plus 5. Alright, so yes, 6y equals negative 4x plus 9, 3y equals negative 2x plus 5. Now, to truly get these into slope-intercept form, each of these equations needs to have just y by itself on the left-hand side. So for the first equation, we need to divide that 6y by 6. If you do that, you get y by itself. But what you do to one side, you got to do to the other. Negative 4x divided by 6 turns into negative 2/3 x. Plus then you have 9 divided by 6. That reduces to 3/2. So you have y equals negative 2/3 x plus 3/2 for the first equation. That just got converted into slope-intercept form. Now for the second equation, we have 3y on the left. We want to just get y. So you got to divide by 3. And if you do that, you get y equals, now you got to do it to the right. Negative 2x divided by 3. Well, that'll give you negative 2/3 x. Plus Now you got to divide the 5 by 3, you get 5/3. So, we now have both of these equations are in slope-intercept form. You have y equals negative 2/3 x plus 3/2, and then y equals negative 2/3 x plus 5/3. Now that we have them in slope-intercept form, let's deal with the slope of each line. The first slope is going to be negative 2/3. The second slope is also negative 2/3. Well, both lines have the same slope, therefore they're parallel. So line 1 is parallel to line 2. So that would be the answer for this. Line 1 is therefore parallel to line 2. So that is it for determining parallel or perpendicular or neither. Next lesson, we are going to determine the equation of a line. We are going to reintroduce point-slope form of an equation. That's going to be instrumental in helping you determine the equation of a line. So I hope everyone has a good night. Take care.